All right, section 2, moving into processes and logons. Now, we are going to cover common processes that run on Windows all the time, every time, so that you're familiar with these names and have some familiarity with common Windows processes to be aware of, so that if you open this up, you'll be like, oh, I know what iExplorer is, I know what Explorer is, I know what Scissors is, I know what spoolsv is, I know what svc host is, as these are all common Windows processes to be aware of that will be running every time a Windows operating system is in place, and they will always be performing the same function for that process. Keep in mind, svc host is the most common name for malware out there, so just because it's not uncommon for a Windows system to have 30 plus versions of svc host running. But that discussion is a bit advanced for this slide or section. But at a general sense, if we're not talking security, these will always be the common names that are generally non-malicious for a Windows operating system, as they are always going to be running. So starting with csrss.exe, I just call that Scissors for short. This is the client-server runtime subsystem process, and it's obviously critical for providing the console window and process management services, responsible for creating and deploying threads, managing the system console, handling graphics, and input, output, your I/O operations. So Scissors, always going to be present on your Windows operating system. Kernel 32, this is the base library. DLL stands for Dynamic Link Library, so it's no longer an executable. It's a shared library that provides core operating system functions for memory management, process and thread management, I/O operations. Kernel 32 DLL. User 32 DLL, this is the user API client library that provides functions for creating and manipulating Windows menus, dialogues, and controls in the GUI applications. NTuser.dat, that's going to have all of the specific configuration settings for a particular user. It's going to have information about that user's preferred desktop settings, program settings, and user preferences. And conhost.exe, this is the console Windows host process responsible for hosting console Windows, handling input and output operations for command line processes. It's used by the command prompt and PowerShell environments that we've seen before. So it's going to be, if you've ever seen a process tree, if you're working in an EDR tool or something that displays parent-child relationships, if we have PowerShell.exe open and we exit out of it, conhost.exe will be a following process for hosting that console Windows, handling the input and output parameters for the command line arguments that we're passing to it. Very, very common process. So we're going to have another slide here on Windows processes to be made aware of. There's definitely more than the 12 or 10 that we're going to cover here, but do you need to memorize all of what these do? No. It's more familiar to be aware of the main names that you see, to be like, oh, I know what that is. So when you pull up your task manager, or if you're trying to analyze something that's running on your task manager or on your system, you can kind of be familiar with, okay, I know that this generally is found on every Windows operating system. It's essential to the core function of the Windows OS. And you can always Google the name if you forget, because you're not going to memorize what all of these do, probably just a couple of them. And it's just a way to increase your awareness about common processes that are available and usually running, or definitely always running, on the Windows operating system. So this second slide here, just a continuation. Wininit.exe, that's your Windows startup application. It's responsible for starting system services and processes during the boot process. We're going to talk about Wininit later on. Services.exe, you're going to see a lot of services running. It's the services and controller app, critical system process responsible for managing system services and processes. LSASS.exe, that's LSASS. Some people abbreviate it as LSA, or some people call it LISA. I've never called it LISA. I always call it LSASS. It's the local security Authority Subsystem Service. That's a mouthful. If there is one to memorize, it would be LSAS. It's a critical system process responsible for enforcing security policies on the local system. This is the process that is responsible for authenticating users, validating the username and password for their logon credentials, and enforcing access control policies. So some of you maybe heard of Mimikatz. Mimikatz is developed by a Windows administrator who intended to have it be for good use, and now attackers and threat actors leverage Mimikatz to run on the system and dump the contents of LSAS to memory. And since LSAS is what's storing and managing all of your usernames and passwords, it will dump the contents of LSAS to another file, where they can then take that file and crack all of the passwords offline to then try and gain access to a username and password account that may have more privilege than your regular user account. Maybe they're going for an administrator account. So familiarity with LSAS, thinking about Mimikatz as the tool that dumps the contents of LSAS to then crack passwords offline. Thinking about LSAS, we're thinking about the SAM, the Security Account Manager. We're going to see local logon processes and how LSAS goes out to the SAM to verify the credentials, and the SAM says, yep, that's good, passes it back to lsas.exe to then allow the user to log on. LSAS is a big one to be familiar with. WinLogon.exe, this is a logon. It's doing that. You're logging on, and it's managing user logons and authentications. It's launched by the Windows Sessions Manager, smss.exe, and provides that interface for the user logon and authentication. So WinLogon, this is where you have your username and password value and your little GUI prompt there. That's WinLogon.exe. We're going to cover these later on when we talk about a local logon series of events. So these names will pop up. And then the last one I wanted to cover is just Explorer.exe. That's this guy. This is your file manager. That yellow folder, the Windows Explorer on the bottom of your taskbar, that is Explorer.exe. That gives you your GUI interface for your file system that you pull up. I'm sure all of you are familiar with Explorer, and it's launched by WinLogon.exe. So again, we're going to talk about the series of chains that happen for what process launches what for a local logon, but basically, after you go through all of this, Explorer will be launched up by WinLogon, and you'll have access to Explorer.exe to access your file systems. Here's just a picture of me in my task manager showing you what LSAS would show up as, the local security authority process. If you were to right click into that, and there's our SAM right there, Security Accounts Manager loading into LSAS. If you say, click on this, right click and say, show me file location, should be running out of System 32. You can talk more advanced concepts about if you see LSAS running outside of System 32, that's probably malicious. Same for a lot of these common Windows processes that you're seeing. They should all be running out of System 32. And if they're not, kind of a red flag from a security perspective. All right, a quick slide here on the user mode startup. Not going to spend too much time on this. I think the logon for a local logon series of events is more important to know, but basically on a Windows operating system, the user mode startup is as follows. ntuser.dat, that's going to have all your user-specific configuration settings loaded from the registry hive that contains it. That's going to launch explorer.exe, which will launch userinit.exe, and that's going to load your user level startup scripts and set the user environment. You'll have winlogon.exe appear. That's going to be the GUI where you put in and manage your logon for your username and password. You'll have services start, LSAS will go, and SMSS will also kick off for launching your system level processes and services for boot. That's about all the time we're going to spend on that. Just wanted to make you aware of it. I wouldn't memorize anything on the slide. At minimum, I hope it just makes you more familiar with these 7 Windows processes names. All right, this slide is rather important just for good general knowledge of what's happening when you log on locally to your computer. So this is the local logon process. So you, as the user, you're going to press Control-Alt-Delete. This is going to initiate that interactive logon. Remember we talked about user accounts and service accounts. User accounts require that interactive logon. So you have to interact with Logon UI, that GUI that pops up for your username and password, and interactively interact with the operating system to put in that information. If we were dealing with a service account, there is no interaction here. It's a non-interactive logon so that it can run in the background and perform all of those system tasks. So anyways, sorry for that tangent, but you as the user will press Control-Alt-Delete, and that's how you're going to initiate the interactive logon to start. Then WinLogon.exe is going to start up, and it will launch into the logonui.exe. This is where you'll have your username and your box there for the password that you put in. And that is the Logon UI. Logonui.exe is going to collect your user credentials, and then it's going to pass them to Lisa. lsas.exe is then going to go to the SAM, the Security Account Manager, and the SAM will either approve or disapprove the values that are stored based on its tables for username or passwords that it's storing as the correct values. And if it denies it, you will have a failed logon or a 4625 event occur. If it approves it, your logon will start to be initiated as successful, and you will have that 4624 Windows event ID be displayed. So after the SAM approves it, it's going to send it back to lsas.exe. lsas will then send it to winlogon.exe again, and it's going to have an access token passed to it that came from the SAM, and the winlogon with that access token will initiate userinit.exe, and userinit will launch the explorer.exe, and it's also going to have a copy of that access token for the user, and you will have logged on to your local workstation, and you'll have your local access token value with you so that you can go off and do access to File Explorer. You can access other system resources, etc. So a good slide to remember and be familiar with is the local logon process, the series of events that occur. I tried to break this down as simple as possible for you, and the big takeaways being that it's an interactive logon where you're leveraging LSAS and the Security Account Manager for local logons, and at the end of it, we're launching and being approved to access explorer.exe, and our desktop will load up. Another slide covering Windows local authentication, just kind of showing the progression here as security has gotten better, hashing algorithms and mathematics have gotten better, starting with the landman hash, the LM, using a hash algorithm for data encryption standard, DES, and then the better reversion going from new technology landman version 1 to the new technology landman version 2, just showing the progression of increased security, what it used to be in the 80s for Windows local authentication using LM, 1993, revamping it, having a better hash, having fixed some of the security issues surrounding the landman hash. These are all vulnerable to cracking attacks, so they fixed that, but then this became vulnerable to pass the hash attacks. And then in 2000, they released NTLM version 2, and it's more advanced and has greater security than the previous revision. But the greatest takeaway to be aware of is that the most secure way to authenticate is going to be using Kerberos, and that's going to be over domain environments, going to be using the domain controller in Active Directory to do so. Some of the main differences here for LM, NTLM, and NTLM version 2 versus Kerberos, which could probably be in this column here, advancing security. This is going to be using a ticketing system, and these are kind of using a handshake to exchange the tokens that are going around for the authentication. The ticketing system and the mathematic algorithms and steps that have to take place for Kerberos just makes it a higher level of security. So just wanted to be aware of these terms. LM, NTLM version 1, version 2, and then Kerberos is pretty much what we're using today to authenticate over the domain, as it's the latest and greatest revision of security that we can offer for performing authentication on the Windows operating system.